Hello everyone and welcome back to the channel. Today we're going to be diving into SQLAlchemy to design and implement the database architecture for a blog platform. We'll cover table design, set up the relationships between them, and write some Python functions to demonstrate how you can use this database. So let's get started. So imagine we want to create an online platform where users can write blog posts, categorize them, and tag them with different keywords. Other users can also leave comments on these posts. So right off the bat, we know we need a table for users, a table for posts, a table for comments, a table for categories, and then a table for tags as well. So we go ahead and draw out the users table, having an ID, username, and email. Then we will go ahead and draw up the post table with an ID, a title, content, and then we have columns for user ID and category ID, and I'll talk about the category ID in a minute. But this user ID will indicate that it will be a relationship with the user. And it'll be a one-to-many relationship, meaning that one user can have many posts, but each post can only be associated to one user. And so from here, we can go ahead and create the comment table. This will have an ID, a column for content, and then a column for user ID, and a column for post ID. And we need both of these columns here since a user can create a comment and the comment will go onto a post. So here, this will be another one-to-many relationship, where one user can have many comments, but each comment can only be associated to one user. And then it's the same relationship with posts. One post can have many comments, and each comment can only be associated to one post. So next up, we'll go ahead and create the category table. This will have an ID and a name for the category. And this will be a one-to-many relationship to our post table. Each category can have as many posts associated to it as we want, but each post will only be under one category at a time. And next up, we'll create the tag table. This will be set up the same as category, except for this one, we want posts to have many tags instead of just one. So we want this to be a many-to-many relationship. And in order to do this, we need to create an association table. So we'll create this and call this post tag, where it has a post ID and a tag ID. And so each tag can be associated to many rows in the post tag table, giving this a one-to-many relationship from tag to the post tag. And then same thing with the post to the post tag, also has a one-to-many relationship. When we set this up, SQLAlchemy will go ahead and automatically do this for us, and we will not have to manually manage this relationship setup once we have it set up in the files. And so doing it this way will basically just give us a many-to-many relationship just like this. So let's hop into the code. So here we will have two different files. We have the app.py and the models.py file. So we'll start in the models.py file. So in here, we have all of our imports here at the top. Then we have a base class inheriting from declarative base, giving us an ID that's a mapped int with the primary key equals true for each of our tables, so we don't have to manually add this to each table. So we have our class user inheriting from our base with a username and an email. And then it has a list of posts right here that will backpopulate the user field on the post table. Scroll down a little bit, we can see this user right here. This will automatically get populated whenever we add a new post here. And then same thing here, we have a list of comments associated to our user. And we have our post table with the title, content, user ID, and category ID. These IDs referencing the other table are necessary when having a one-to-many relationship. So whatever table's on the many side of the relationship will need these IDs. Then we have our user, which is just one user per post, backpopulating the post variable up here. Then we have our category, it's just one category per post as well. Then we have tags, which is a list of tags, and this is our many-to-many relationship. So we have our secondary table that it's used as a linking table is our post tag table, and we'll see that in a minute. But it will backpopulate the post variable on our tag table. Then we also have a list of comments referencing back to our post variable on the comment table. And so here's our comment table with the content, user ID, post ID, and then we have the user that is associated to this comment, so just one user, and then one post also associated to this comment. Then we have our category table with a name, and then a list of posts that are associated to this category. Then our tag table with a name, and then a list of posts associated to the tag. This is also using secondary equals post tag. Both this secondary and the secondary on the post table need to be the same in order for this to link correctly. So it also backpopulates the tags variable here on the post table right here. And then this post variable is being associated with this tag variable's posts. Then we have our association table of post tag. And so here, this just keeps a reference of the post ID and the tag ID. And SQLAlchemy will automatically manage this for us, and we don't have to touch this table unless we wanted to add some kind of attribute that depends on both a tag ID and a post ID. Then we have a get session function where we get an engine of our database. We will go ahead and create the tables if they don't already exist, and then get a session. So then we can use the session to perform transactions or different kinds of queries on our database. So we'll hop into the app.py file now. So in this app.py file, first we go ahead and import session, user, comment, post, category, and tag, all from our models file. Then we will go ahead and create a function called add user, where we pass in a username and an email to create the user. First, we want to check if our user already exists. So we can do that by saying users equal to session.query passing in user, filtering by the username being the username we're trying to add the user for, and the email we're also trying to add for the user. And we're getting the first entry. So this will either return one user or none. And so by doing this, we can say if the user is not none or just if user, we can return a message saying that the user already exists with that username and email, and then go and return out of this function. But if the user doesn't exist, we can go ahead and create a new user, giving it the username and email passed in. Then we can go ahead and add it to our session and commit it to go ahead and save it to our database. Then we'll go ahead and print a message saying our user has been added. So following this logic, we can do the same thing with category and tag. You can add this check to both category and tag, but for this example, I'm just going to go ahead and leave it as it is. So coming down to the bottom, we'll go ahead and use these functions and test that they actually work. So we'll go ahead and run the file, and we can see that the user was added, category added, and the tag was added. Awesome. So we'll go ahead and jump into the next function of adding a post. And this is a bit bigger, so I'm going to just explain over what's going on here. So first, we have to pass the username, a title, content for the post, the category the post is associated to, and a list of tags for the post. So here we'll go ahead and query our user table, getting the user with this username, and then getting the category that we're trying to associate the post to. And we'll say if either of them doesn't exist, so if either of them is none, then the user or category couldn't be found and return out of the function. So stop adding the post. But if they both exist, then we'll go ahead and create a new post, giving it the title, content, user, and the category. We'll go ahead and add it to our session here. And then for our list of tags, we'll go ahead and get each name in our list of tags, get it from the database. If it doesn't exist, go ahead and create it, add it to the database, and commit it. And then we will add that tag to our post tags. Then after we're done, we'll go ahead and commit it and print out a message. You also will have to comment this out. It's going to try and create another user with the exact same username and email, and it's going to throw an error. So comment that out, and then we'll go ahead and test this add post function, giving it the username, a title, content, category, and tag. We'll go and save it and run it. And we can see that it was added to the test user. And then we actually don't need the session.commit right here. So you can delete that and it will work just fine. Now we'll move on to adding a comment to a post. So in order to do that, we'll need a username to associate with it, a post ID to associate with the comment, and then the content of the comment. So first we get the user and then the post. And we're saying if either of them don't exist, then we'll go ahead and print out they couldn't be found and return out of the function, stop from adding this comment. Then we'll go ahead and create the comment, add it to the session, and commit it. So we go ahead and call the function, passing in the test user, giving the post ID of 1 as the first post that we added already, and then gave it some kind of comment. So we go ahead and run this, and we can see the comment was added to the post with ID 1. So for this next one, we'll get started into actually retrieving data from our database. So the first one we'll do is fetching post by tags. So in here, we passed a list of strings that are tag names. And this will return a list of posts. So in order to do this, we do session.query of post, and we do a dot filter, and we'll say post.tags.any. This will just mean if this post has tags that meet any kind of condition that we're about to pass, it will return true and give us that post. So in this case, we're doing tag.name in our tag names. And so this is the same as doing something like name in a list of strings, and because this will return true. But if we had something like this, this would return false. So if there's at least one tag associated to the post that's in our tag names, then it will return that post for us. Then we want to do .all, and then we'll say for each post in our list of posts, we'll go ahead and print the title of the post. And then for each tag in the post tags, we'll go and just print the name of the tag. So if you go ahead and run this, it should print out the post and the tag associated to it. I ran the create post function twice, that's why it's showing up twice here. But it returns this list of posts. So then you could say posts equals this, and then do something with this, whether you have an API, you want to return it to the UI, or however you want to do it. Now we can do something similar where we're fetching post by a category. So we pass it in a category name, and we can do it kind of similar to how we just did fetch post by tags. But with a different approach, we'll say category is equal to session.query of category, filtering by the name is the category name we passed in. If the category doesn't exist, we'll go ahead and print that and then return. But if it does exist, then we'll say post is equal to session.query post, and we'll filter by post.category is equal to this category right here. And we'll get all the posts that are in that category. Then we'll say for post in post, we'll print out the title, the user, and the category it's associated to that post. So I'll go ahead and call in this function, passing in technology. We'll go ahead and run this, and we can see it did print out the post with the category. And this is not a very nice looking thing, but this is the category that we passed in. But we can change this to .name to access the name of this category. Go ahead and run this again, and we can see the category is technology. So now we'll look into some delete operations like deleting a comment. So we'll pass in a comment ID, which will be an integer. We'll go ahead and query the comment table, getting this comment with that ID. If it doesn't exist, then there's nothing to delete. But if it does exist, we'll do session.delete of the comment and commit it to save the deletion to the database. And then print out that it was deleted. So if we do delete comment 1, go ahead and run this, we can see comment with 1 was deleted. But if we go ahead and run it again, the comment with ID 1 is not found since we already deleted it. And then you can do the same thing with posts, users, categories, tags by following the same kind of delete structure. And the last thing we'll look into is updating data. So we can create a function called update comment to go ahead and update a comment that already exists. So we'll pass in a comment ID and then the new content of the comment. So it's very similar to delete where we get the comment. If it's not found, we'll return and say that it's not found. But if it does exist, we'll just say comment.content is equal to the new content and then commit it to save it and then show that it was updated. And so that's the basics of how you can design and implement a blog platform using SQLAlchemy. We've covered the database architecture, relationships, and even demonstrated how to use it in real-world scenarios. If you found this video helpful, be sure to like, subscribe, and I'll see you in the next one.